Hi, welcome to educator.com. Today we're going to be talking about scatterplots. So first we're going to talk about how scatterplots are different from previous visualizations. So because of that, we're going to go over a little bit about what those previous visualizations all have in common. Then we're going to compare and contrast those with scatterplots. And finally, we're going to go on to describing the different aspects of a scatterplot versus those other distributions we've been talking about before. All right, so the previous distributions we've really been talking about have largely been about frequency distributions. And here we're really talking about just one continuous variable, like height or age or number of friends on Facebook. And then we're asking, how frequent is this value? How frequent is it to have 200 friends on Facebook? How frequent is it to be 6 feet tall? Now, that frequency distribution, it looks like there's two variables because you have an x-axis and a y-axis. But really, it's one variable, height, and the frequency, which is not really a variable. It's just sort of counting how many of that height you have. But we have looked at some cases where we compare two different variables. But usually, it might be comparing two groups on some continuous variable. So we might compare male and female heights. But really, we're only looking at one continuous variable, height. The other variable is a categorical variable, the two groups, right? That's how we get the two groups, something like gender, right? And so although we have that, still the fundamental basis is that we've really only been looking at one continuous variable at a time. Now these frequency distributions, we've drawn like histograms and different things. They often look like this, and they're summarized by shape, center, and spread. And usually by center, we mean something like mean, and by spread, we mean something like standard deviation. Now, that's going to be sort of the past. Now we're moving on to scatter plots. So here's how scatter plots are different. Now instead of having one continuous variable, we have two continuous variables. That's the big key difference. And because of that, one axis is going to have, variable 1. And instead of putting frequency here, we're going to put variable 2 here. Whereas in frequency distribution, we had variable 1 here, and then we had that frequency of variable 1 here. Notice here there's no explicit representation of frequency. There's no number that we're plotting to represent frequency. And each axis is going to represent a variable. And we're summarizing these distributions by shape, trend, and strength. Here it's going to be called a scatter plot because each case is now going to appear as a dot. And each case, for instance, each person on Facebook might have variable 1, number of friends, as well as variable 2, how many photos they've uploaded, right? And so each dot represents one person, but two variables within that person, two values within that person. And because of that, it's called this scatter plot because it could look like somebody just scattered a bunch of dots on this graph. So it makes sense why it's called a scatter plot. Notice that here, it doesn't quite seem like we're really interested in the center of one dimension. We're sort of interested in the center of two dimensions. And so because of that, trend is going to be sort of like center, and strength is going to be sort of like spread. Sorry. And so these concepts are concepts you've thought about before, but we're translating them from one dimension to two dimensions. And so spread used to be something like this, but now we're talking about spread in two dimensions. And that's going to look a little bit different. All right, so let's talk about these particular summary values of shape, center, and spread. And remember, frequency distributions are always what we call univariate in terms of continuous variables. It might have two variables, but one will probably be categorical. So when we talked about shape, we talked about things like unimodal, is it symmetric, does it asymptote, right? So those are kind of the features that we were looking for. Is it sort of normal? Is it uniform, right? Those are words that were sort of buzzwords when we talked about shape in frequency distributions. In scatterplots, we're largely interested in a couple of different shapes. One shape might be that the dots sort of fall in a line, right? So is it a linear scatterplot, right? Another potential distribution is that the dots might fall in sort of a curve. So is it curvilinear? And the final it's sort of a shape that we're interested in is maybe there's just sort of no shape and it's sort of blob-like or cloud-like, right? And this isn't sort of an official word, but you know, cloud might be one way of thinking about it. So those are sort of different shapes that we're sort of interested in. How linear is it? Is it curvilinear? Is it just a big cloud, right? Now let's talk about center. The way we talked about center before was that we were interested in things like the mean, median, and mode, right? And a lot of times we use mean, either signified by mu or x bar, depending on whether you're in a population or sample. Trend really has sort of the same idea as center. So you could think about this as a version of center, except it's a center of two variables, not just one. And here, it's not really useful to have a center just dot, right? Because that's what we had before. We had a point mean, so it was like a particular point. But now what we're interested in is, let's say we have a whole bunch of dots scattered here. What we might be more interested in is a line of some sort that describes the relationship between all these points on these two variables, right? So here, we're not just interested in a point center, we're interested in sort of a line center. So I'm going to adjust this to be line center rather than a point center. And that line is going to be called, the official term for that is regression. So that's going to be the regression line. The final idea I want to talk about here is strength. And I want to sort of tie that to the idea of spread that we talked about. Before, one important idea of spread that we frequently talked about was standard deviation, expressed as sigma or expressed as S, big S. Let me write that a little bigger, right? So those are sort of two ways we've talked about spread before. And that gives you a one-dimensional spread. But what might be more useful here is something like a two-dimensional spread. So here we have our dots, we have our line, but now we're interested in how spread out these dots are. And so you could think about it as all these little distances away from that line. What's that spread away from the line like? And so you want to think of this as a multi-dimensional spread. It's not just a one-dimensional spread, it's a two-dimensional spread. So you could think about this as, you know, spread around line, right? So before this was spread around a point, but now it's a spread around a whole line. And we're going to call that correlation. And so if it's very strong, it means that it sort of hugs that line really closely. So that's a strong correlation where it hugs it closely. A weak correlation means it's sort of hazy, like it's sort of very, very far out and spread out from that line. And a moderate correlation is there's a little bit of spread, but not too much. And all of this has changed because now we're talking about bivariate distributions. And when we're talking about bivariate data, we're no longer just interested in points and spread around a point. We're interested in things more like lines. Let's move on. All right, so here's an example scatter plot. Remember that data that we've looked at in the past with 100 friends on Facebook, and we wanted to look at whether the number of friends people have sort of correspond to the year of birth. Now, this is not saying that there's lots of people necessarily born in 1997, right? This is not what this means. It means that this, right here, this dot, is actually a particular person. So it's a case of one person. And this means that this one person was born maybe in 1993. But they also have an inordinate number of friends. So they have, like something like 1,900 friends, right? So that's what these scatter plots mean. You can't interpret this as being a very popular year to be born anymore. Now you have to say, this particular person was born in this year and has this number of friends. So if you look at another point, like this one right here, they have very few friends, none actually, but they're born in 1978 or so, right? And one thing you might notice about this is that there's sort of this shape here. It seems to rise almost, right? So if we drew some sort of line that would cut through this, maybe it would be a line like this, where these people, they're as you see the year of birth increase, so these people are sort of younger, right? They were born more close in history. They seem to have slightly more friends, right? And if you drew a curve to sort of fit this, that might actually be better, right? Where it seems that, the people born, up to 1985, they have relatively lower number of friends than the people born sort of afterwards. That seems to shoot up more. So this is an example of a scatter plot, and these lines are example sort of rough lines that might be regression lines, lines that sort of fall in the middle of all these points, where these points are sort of roughly below it, these points are roughly above it, and if you counted all the distances up, that would sort of average with that line. And so let's think about that as the trend. So that's that trend, and the strength is that it seems maybe moderate strength. It's not hugging the line quite closely, but it's not just this amorphous blob either. All right, but usually we don't plot things by year of birth. I mean, sometimes we do, but you could easily change year of birth into their age, right? By just using 2011 minus whatever their year of birth was. And so here I have age plotted on the x-axis, and here I have year of birth plotted on the x-axis. But on the y-axis for both of these graphs, it's their number of friends on Facebook. So these are scatter plots, and you could know that just by looking at these two variables. If one of them says frequency, right, then you know it's not a scatter plot. But if they're both variables, then you know it's a scatter plot. Here we see sort of this this positive association. The higher the year of birth, the the higher the number of friends, right? So as one variable gets greater, the other variable also seems to increase, and vice versa. As one variable gets less, the year of birth gets less. The number of friends also seems to be quite low. On the other hand, if you look at this graph, we see sort of the exact opposite trend, where as age goes up, the number of friends seems to come down. Now, so they're sort of moving in opposite directions. As one variable goes up, the other variable is coming down, and vice versa. As you go down in age, as you go sort of this way on the x-axis, then you see friends sort of going up, right? Now, this is what we call a positive association, where the variables are sort of coupled to each other in the same direction. So we'll call this positive association. But when we plot age instead of year of birth, we see a negative association. So we mean negative here, not as in direction like going up or down, but negative as in they're linked in a way that's the opposite of each other, because negation also means opposite, right? So as one goes up, the other goes down. As one goes down, the other goes up, right? And it's important to note that these are just associations. It's not that the year of birth is causing them to have more friends. Maybe it's some other variable that matters, like when you were introduced to Facebook or something like that, what age you were introduced to Facebook, or how comfortable you are in using the computer. So just having a positive association doesn't mean there's a causal association, and that's where you get that famous saying, correlation does not equal causation, because another word for this association is also correlation. So just because you have this nice association, either positive or negative, it doesn't mean that they cause one another. All right. And let's think about why year of birth has sort of the exact opposite effect of age, right? Has the opposite association with friends on Facebook. Well, if you think about year of birth really means that when you're increasing the year of birth, you're decreasing the age, right? So these two variables actually have a perfect negative association, right? As one goes up, the other goes down. So as year of birth goes up, 1994, 1999, 2000, right? The age is going down and down and down. And so that's what we call a negative association. Now, it's not really that one is causing the other. They're sort of the same idea. So they're perfectly negatively associated. And that's why correlation or association does not equal causation. Okay. So those are some examples of some scatter plots that you might see. But there's a couple of different concepts that I want to go over. Just one is this idea of linearity. That's going to be very important to us. So linearity is just talking about how liney, how like a line it is, right? So I want you to know this distinction between linear and curvilinear. Right? So when you think about linearity, think about linear versus curvilinear. And when you think of strength, I want you to think of it as if we have, as if we're really talking about spread, right? So just translate that in your mind as spread. So if we have these dots, and they're a little bit spread around the line, right? So there's a little bit of spread here, right? And you could think of it as averaging all these little distances away from that line, right? Versus if you had something like this, that was much more widely spread around this line. Right? So there's a lot more spread going on here. And if I just added a few more out here, I would have even more spread, right? So when you think of strength, think of it as spread, right? And so I want you to think of it as, you know, strong, moderate, or weak, right? So you could think of strength in those terms. And then finally, I want to introduce this concept of consistency that we really haven't had very much of until now. Consistency just means how consistent is that strength? Is it strong all the way through? Is it weak all the way through? Or is it inconsistent? So an example graph might look something like this. This sort of starts off looking very linear, right? But then down here, there might be more variability, right? So here, you could see that if we drew a regression line, here we'd have very little spread, but here we'd have a lot of spread, right? So that would be, this would be inconsistent. So one is sort of constant spread versus inconsistent, right? And so an example of constant might be something like these, where it's pretty constant. This one is sort of less constant because there's this peak out here, but here there's less variability, right? So this is an example of constant. This is another example of inconsistent. So you want to think of this consistency as applying to strength. Is that strength consistent all the way through, or is it sort of different all the time? And just to point out something, in all of these graphs that I've drawn here, just by coincidence, I've drawn what are called negative associations, because as one variable, as we look at values that are greater on one of the variables, like for instance here, this variable seems to be very low. The value is very low here, right? And so these are all examples of negative associations. And one easy way you could visually see this is that they all have that negative slope where it's slanting this way instead of that way, right? Positive slopes would be that way. All right, so now let's talk about how to summarize a scatter plot. We've seen some of the different features of it, but here's how you sort of wrap your mind around a scatter plot. And I've sort of distilled it into 5 steps so that it'll be easier for us to sort of knock through all of them. First thing you want to do is identify the cases and the variables. Oftentimes people look at a scatter plot and they see the overall shape. They see, oh my God, it's a line, right? But then they forget what the dots are. It's sort of like seeing the forest but forgetting what the trees are, right? So first thing you want to do is identify what the cases are, and then identify what the variables are so that you know what you're talking about. Then you want to describe the overall shape. Talk about the linearity. If there are any clusters, you want to identify those. If there are any real outliers, you want to be able to identify those as well. Then you want to describe the trend, or you could think of this as the positive or negative association. So is it slanting to the positive side or slanting to the negative side, right? So you could think of this as going that way or going that way, right? And then step 4 is describe the strength. And for now, you could just think of it as eyeballing it, strong, medium, or moderate, or weak. But we'll talk about exactly how to do that later. And then any potential explanations for this relationship. Now, this is just, this is sort of an extra step. Sometimes you may not need this, but it's often helpful to do. And it's really critical that you remember not always causal. there might be a causal relationship, but not always. And it behooves us to think of potential explanations that are not causal. So why might they have this positive association? Why might these two variables have this negative association? And that's going to be really important for us to figure out. But it's good for us to think about, okay, maybe it's causal, but maybe it's not. And those are actually harder to think of sometimes because we sort of jump to the causal explanation. But one thing that might be the case is some third variable that explains this relationship, and it might not be these two variables that are that important. Final thing is when we describe the trend, right now we're just going to be describing it sort of roughly. We're going to be eyeballing it and sort of describing it. But we're going to learn how to describe it in a very precise quantitative manner. And when we do that, that's going to be called finding the regression line. Because that really is going to be the equation of that line. And then we're also going to, right now, just describe the strength sort of roughly, but later we're going to find precise quantitative values for strength, and that's going to be called correlation. All right. Now let's move on to some more examples. So first, here's a graph, and what I want you to do is just identify those, to just go through those 5 steps of summarizing a scatter plot. So remember, it's describe the cases and the variables, talk about the shape, talk about the trend, talk about strength, and then think about potential explanations. So I'm going to introduce you to this thing called gapminder.org. It's this wonderful website that sort of puts together all these different databases of really interesting information from all over the world and puts it in beautiful graph form so that we can look at the data in new and very interesting ways. So here you could go to gapminder.org if you want. I've already pulled it up on my browser. And you want to click on, I think it's World, Gapminder World. I've actually clicked on Health and Wealth of Nations. And so if you want to follow along, you could do that too. But I want to show you this graph. Here, what we have on the bottom is income per person. So GDP per capita. So this is the entire amount of money that the economy of that nation makes divided by how many people are part of that nation, right? And so that's income per person on the x-axis. And notice that it's in log form. That means that it's sort of spread out. The low numbers are sort of spread out and the higher numbers are sort of squished together because they've taken the log of the income per person. And also here we have life expectancy. So that's the average number of years that people live in this country. And so let's start with first things first. Step 1, what are the cases? Well, these cases actually represent countries. And if you put your cursor over these dots, it'll tell you which country it is. And in Gapminder, one nice thing is that you know the population of that country just by the size of the dots. So all the dots are different sizes. But let's answer our 5 questions, getting back to more statistics things. So the first thing is that these are nations, right, that are represented, and it's their income per person by life expectancy, right? So that's the first thing. We've figured out what the cases are and what the variables are. The second thing is the shape. We'll say roughly linear, right? Maybe a little bit curved. we've seen some clusters of these, we've seen some of these geographic clusters, but not really in terms of the actual dots. If you thought of these all as just black dots, they would create roughly this line. Now let's talk about the trend. The trend definitely seems to be a positive association. So as GDP is greater, life expectancy is also greater. As GDP is lower, life expectancy is also lower. So they're linked in this positive way, not oppositely linked. And let's talk about spread. We could imagine a line and see somewhat of a spread. I would say maybe this is a moderate spread. I mean, it's not like you see a perfect line, but it's not like so spread out you can't see the line either. So maybe moderate might be a good answer for that. And number 5, let's think about why this might be. Well, we want to consider a couple of things when we think about the relationship between these two variables. We want to think about how variable 1 might impact variable 2, but we also want to think about how variable 2 might impact variable 1. And finally, we might want to think about how some third variable, variable 3, the mystery variable, might impact both 1 and 2, right? So we might think, okay, if you have a higher income per person, if you're a richer country, you have better health care, better facilities, better sanitation, right? So you might have greater life expectancy. Also, if you have greater life expectancy, you could invest in more education and more long-term things, and because of that, that might increase income per person. You might be able to share more cultural capital, who knows, right? Or it might be some third variable. Maybe a government that governs so well that you have this great income also has good health care and other things to have great life expectancy, right? So it might be, or different things. Or maybe like some countries have war, right? So if you have a lot of war, then your economy suffers, but also life expectancy suffers, right? And so that's like a third variable, right? So it might be a whole bunch of different things. So here, it's such a long answer, we're not going to write it down, but you know, you want to think about all the different ways that they might impact each other.